Hi, my name is Jim Young. I'm an applications engineer at ON Semiconductor, and today I'd like to talk to you a little about LED lighting. In particular, we're going to be talking about higher power applications suitable for street lights or high bay lights, which you might find in a large warehouse. This particular solution is the NCL 30030, which is a two-stage LED driver that is configurable for either constant voltage or constant current output. So here's a demonstration board that we've developed based on this IC. We have the power factor corrector stage in the front end, and then on the back end we have a two-switch flyback converter that takes the voltage from the PFC and controls it down to either the current or the voltage controlled for the output. It has an input range of 90 to 305 volts AC, and it maintains power factor above 0.95 with a THD much below 10%. We have a lot of protection features built into this. Not only does the IC have an internal over temperature protection, but there can also be external temperature protection that you may be putting on the LED itself in case that overheated, you don't damage your LEDs. The demo board has been set up with multiple interfaces for dimming. A very standard dimming interface in the industry is a 1 to 10 volt DC dimming. There's also 0 to 5 volt dimming supported, as well as 5 volt PWM. The PWM may be a 200 hertz waveform where you adjust the duty factor to adjust the brightness. It'll also support a 2-input stage. For example, if you had a motion sensor, it would operate at a low level when there is no activity, and whenever there's activity in the area, it would step up to a full brightness, therefore saving power whenever there aren't any occupants in the area. I've got a setup here with an LED load, and we're using this power supply to provide the 1 to 10 volt interface for dimming. So we're going to watch the voltage on this control line and the output current that's going to the LED. Right now it's been set up with a baseline of about 62 milliamps, and we're running at about 210 volts on the LEDs with 0 volts in. As we increase the control voltage, we can see that the output current is in fact increasing, and when we reach a maximum of about 10 volts, we're running at about 720 milliamps. And again, this is with a 210 volt load, so we're outputting at about 150 watts. Even though this is a two-stage solution, we're still achieving about 90% efficiency, along with, as I mentioned, power factor above 0.95 and a very low THD. So this provides a very cost-effective solution for higher powered LED applications.